Hello students, welcome to the fifth session of our first module in Mechanics of Solids. Students, today I am going to do a problem related to the topic we have studied in the previous session. So we have studied to write this state of stress at a point. State of stress at a point. A point. So how do we write that state? So it was in a matrix form, sigma xx to xy to xz to yx sigma yy to yz to zx to zy sigma zz. So this is how I write. So ij, this is a stress at a point in matrix form. Tau ij, I and j varies from x or y. It may be x or y. So students, there is a topic called equality of Shear. Equality of Shear. So students, there is a derivation for this particular equality. So, but in your syllabus, it is not asked to derive, but just state this equality of Shear. So derivation you will be studying in your higher classes, like in AMOS, Advanced Mechanics of Solids. So what is Shear? Shear, you know, shear stress is nothing but tau ij, right? Tau ij. Okay. So tau ij is nothing but shear stress acting in plane I in direction j, right? Plane I direction j. So students, equality of shear is nothing but tau ij equal to tau ji. So this is called equality of shear. So there is a derivation, but you don't worry about derivation. You are not required to. You are not asked to derive those equations. Okay, equality of shear. So what does it mean? It means tau xy will be equal to tau yx. Tau yz is equal to tau zy. Tau xz equal to tau zx. So all these things are equal. These are that means here shear stress in x plane y direction will be equal to shear stress in y plane x direction. Same way, shear stress in y plane in z direction will be equal to shear stress in z plane in y direction. Shear stress in x plane in z direction will be equal to shear stress in z plane in x direction. So students, we have written the state of stress in this manner, right? Sigma xs, tau xy, tau xz, tau yx, sigma yy, tau yz, tau zx, tau zy, sigma zz. So students, while writing this matrix, you have to note that these two will be equal always. Okay, these two will be equal, and these two will be equal. Okay, so this is the idea between idea of equality of Shear. So hope you have understood that idea. Okay, now we will do a problem. Now we will do a problem on determining the stress vector in a particular, in an arbitrary plane whose direction of cosines is given. Okay. So students, this is a question. So stress tensor at a point is given tau ij equal to, this matrix is given 1 3 2 3 2 1 2 1 minus 1. So just note down as this two value will be always equal, this two value will be equal, this two value will be equal. Okay. So this is the stress at a point. This much units. Okay, units. So this is how we represent stress at a point. So we are asked to determine stress vector and its component on a plane, so an arbitrary plane. So this is based on a Cartesian coordinate, but we are asked to find the stress vector and its component on a plane having direction of cosines nx equal to ny equal to nz equal to 1 by root 3. So we are asked to find this stress, the stress of the point having this much stress in Cartesian coordinate. What will be the stress at that same point when calculated on a different plane having the direction of cosines nx equal to ny equal to nz equal to 1 by root 3. So students, suppose in this question it may ask that you are asked, suppose you may be asked to find the stress vector in a arbitrary plane which is inclined equally to all Cartesian all coordinate axes. Suppose a plane which is equally inclined, which is equally inclined to all x y z axis. So how will you find the direction of cosines? Because and you can apply this equation nx square plus ny square plus nz square equal to 1. So if all the three are equally inclined to x, y, z means all these three are equal. So I will put 3nx square equal to 1, nx equal to 1 by root 3. Okay. So if in the question it is given that the direction of cosines is not directly given, but it is said that the arbitrary plane is equally inclined to all the three axis, then it means each direction of cosines will be 1 by root 3 only. So but in this question it is directly given 1 by root 3, so don't worry. I just tried to make you understand. If it is not given, this is the method to calculate nx. So this identity you should remember. Sometimes these two directional cosines may be given, but nz won't be given. So how to find nz? You just apply these values in this equation. So that's how we will try to calculate directional cosines. So leave it. So our question is tau ij is given. Tau ij is given 1, 3, 2, 3, 2, 2, 1, 1, minus 1. So we are asked to calculate T stress vector with in a plane with nx equal to ny equal to nz equal to 1 by root 3. So this is our aim. So how will you do this? You have to apply the Cauchy's equation. So that is why we have learned Cauchy's equation. Cauchy's equation. What is Cauchy's equation? Tau ij into nx, ny, nz equal to t vector. Or we have written the equation like how did you write those equation? Cauchy's equation: sigma xx into nx plus tau xy into ny plus tau xz into nz equal to tx, right? Similarly, tau y is tau yx nx plus sigma y by ny plus tau yz nz equal to tau y, sorry, ty, t vector y, tau zx nx plus tau zy ny plus sigma z nz equal to t vector z. So all these values, this value is known, this value, all these values are known, right? All these values are known, right? So you will get the stress, the component of stress vector in x direction. You will get component of y, the stress vector in y direction, and component of stress vector in z direction for that particular plane. You will get. So I will try to write those equation once more in values. So what was the value? 1 into 1 by root 3 plus 3 into 1 by root 3 plus 2 into 1 by root 3 equal to tx vector, vectors tx component, 3 into 1 by root 3 plus 2 into 1 by root 3 plus 1 into 1 by root 3 equal to ty vector, 2 into 1 by root 3 plus 1 into 1 by root 3 minus 1 by 1 into 1 by root 3, 1 into 1 by root 3 equal to tz vector. So if you calculate this, you will get the value as tx equal to 6 by root 3, ty equal to 6 by root 3 again, tz equal to 2 by root 3. You just calculate on your own and just check and verify if this value is correct or not. Okay, so this much units. So units is not directly given, so just put this much units. Sometimes in question it may be given, the stress vector will be given in Pascal, so you have to put here Pascal. Since here it is not given, you just put it as units itself. Okay, so we got the components of the stress vector in that particular arbitrary plane, and what is the resultant? Resultant stress vector will be root of tx square plus cy square plus tz square, right? So it will be 6 by root 3 square plus 6 by root 3 square plus 2 by root 3 square. So 36 by 3 will be 12, 12 plus 24, 24 plus 4 by, it will be around some, you will get around some 5.03. Okay, the value will be some 5.03. So this is the stress vector. Okay, now if you want to calculate the normal component and shear component, what will you do? How can you calculate? I told this stress vector is 5.02, sorry, 5.03, right? 5.02 or 5.03, okay, 5.03. This value is also equal to sigma n square plus tau n square, right? So sigma n can be calculated using the equation nx tx plus ny ty plus nz tz, right? So this equation also we have learned. This will be what will be the value? 6 by root 3 into 1 by root 3 into 6 by root 3, 1 by root 3 into 6 by root 3 plus 1 by root 3 into 6 by root 3 again plus 1 by root 3 into 2 by root 3, right? Right? The final value is 2 by root 3, okay. So if you do the calculation, 6 by 3, 2, 6 by 2, by 4 plus 2 by 3. 4 plus 2 by 3 means 14 by 3. So this value will be, the normal component will be some 14 by 3 units. 14 by 3 units. So students, t vector is 14 by 3 whole square plus tau n. Now t vector is equal to 5.02. So this is known, this is the only unknown. So how will you calculate? Tau n is nothing but root of t vector modulus square minus sigma n square. So 5.03 whole square minus 14 by 3 whole square, right? So you will get a value around 1.885 units. So students, this is how we calculate a stress vector in an arbitrary plane whose directional cosines are given. So if you have the directional cosines and state of stress at that point, you can calculate stress vector at that in that particular plane. You can have the XYZ component and also normal and shear component also. So this is the method to solve this kind of problem. So in exam, simple kind of problem will only be asked, so don't worry. I will give some more problems as assignment, so you try to solve it on your own. Okay. Students, very important concept we are going to learn, principal plane and principal stresses. So students, we have seen that the normal and shear stress components can be determined on any plane with the normal or the directional cosines are known. So maybe we can use Cauchy's formula to get those normal and shear stress components if the directional cosines of that particular plane is known. Okay. But some very important questions are to be addressed. Are there any planes passing through that given point on which the resultant stresses are wholly normal? Students, so this is our y, z plane. We have a component like this. So I am taking a point P and cutting it in this plane. So it will, so if you cut this plane, you will get so this plane, right? So this is our point. So if this normal is n vector and stress is this way in this direction, but there may be some planes in which t vector will be in same direction as of the normal vector. What does it mean? This is normal vector and t vector will also be in same direction. There may be some planes through which the resultant stress or the stress vector is wholly normal, completely normal. So this t vector is normal to the plane, right? So n vector and t vector coincides. But if t vector was in this way, it is not normal because it may have a normal component and a shear component. But in this case, it will have a normal component only, no shear component. So what is the plane on which the normal stress is a maximum? What is its magnitude? So here, so in this case, t vector is wholly normal and there is no shear component, only normal component. So the normal stress is maximum in this case. What will be its magnitude? What is the plane on which this tangential or shear stress is maximum? And what is its magnitude? That's another question. There is another question. Another question is there may be some plane where the tangential or shear stress is maximum. It is wholly, t vector is wholly tangential or t vector is perpendicular to normal vector. So here no normal component, only shear component. The shear component is maximum. Which is that plane? So students, the idea of principal plane is principal plane. Principal plane is that particular plane in which in which the stress vector is wholly normal. Wholly normal means only normal component is there. The plane in which the stress vector is wholly normal means t vector is parallel to n vector. T vector is parallel to n vector. Such plane is called principal plane. Here, what is the speciality of this plane? Here shear stress will be 0. Shear stress will be is equal to 0. Why? Because it is wholly normal, then it won't have any shear component. It won't have any shear component. So the normal stress corresponding to principal principal plane is called principal stress. Is called principal stress. Okay. So the principal stress is the principal stress is the value of stress uh, in that plane, which in the principal plane. The value of stress in the principal plane is the principal stress. So what is principal plane? Principal plane is that plane in which the stress vector is normal, completely normal or wholly normal. So there is no shear component. Those planes in which there is no shear stress or shear component, such planes are called principal plane. There the value of sigma or normal stress will be maximum. That particular sigma is called principal stress. So that is the idea of principal plane and principal stress. Have you understood? Have you understood? So students, this is x, y, z, and I am drawing the n vector, and this is here. This is the t vector, the stress vector. Both are in same direction. Means this is a principal plane. So t vector is in n vector direction itself. So it's normally t vector can be resolved in along xy direction, like sigma xx, tau xy, tau is xz, tau yx, tau sigma yy, tau yz, tau zx, tau zy, sigma zz. So this is this is our normal way of writing the components or the state of stress for a particular point P in this particular principal way. Any plane, be it a principal or not, any plane we can. This is a general equation. But t vector can also be written. T vector here can also be written as sigma. Its normal component into n vector, because it has got only because the normal component is only there, no shear component. So t vector can be written in. So if sigma is the normal component, let sigma be the magnitude of this stress vector. I'm not telling this is normal component. So any vector can be written as sigma or a magnitude into the ijk or the direction vector. Okay, this is general formula. Any vector can be written as magnitude into its direction vector into magnitude. That is the way of writing a vector. So sigma be the magnitude of this vector. Okay, let magnitude of t be sigma. Magnitude be sigma. So t vector can be written as sigma into n vector. So this is the way of writing. Also, so we can write sigma xx tau xy tau xy tau xz tau yx sigma yy tau yz tau zx tau zy sigma zz is equal to what? Is equal to what? To t vector or sigma into n vector. So what is n vector? N vector is nothing but nx ny nz, right? Sorry, before the okay, you can write sigma into n vector. So what is the this is tij wait okay. So this into nx ny nz, you get what? Tx ty tz, right? Tx ty tz. So this is Cauchy's equation. So you will get the value of tx ty tz, right? But tx ty tz can be written in this format also. How? Since t vector is sigma into n vector, you can write it as sigma nx sigma ny sigma ny and sigma n is that, right? So this way also you can write. So the previous case and this case are same, so you can equate, right? So because tx ty tz remains, so I can write sigma xx so I can write this equation like this. I am substituting for tau tx ty tz as sigma nx sigma ny sigma ny sigma nz, right? Substituting for tx, this was tx, this was ty, this was tz. I have substituted all these things with these values, right? Okay, now I can write this in algebraic equation form. How? I'm writing this equation. I'm taking this into okay, sigma x nx plus tau xy ny plus tau x z nz equal to what? It should be equal to sigma into nx, right? Similarly, sigma uh, tau xy or tau yx, same due to equality of Cauchy, tau yx nx plus sigma yy here xx ny plus tau, these are tau's, not t, tau x sorry tau y z nz equal to sigma n z. Similarly, tau zx nx plus tau zy ny plus tau sigma z n z equal to, this is y, sorry, this is y, so sigma n z, this is y. Okay, so I am taking this to this left hand side, all these values into left hand side. So I will get sigma x minus sigma xx minus sigma nx plus tau xy ny plus tau xz nz equal to 0, tau xy nx plus sigma yy minus sigma ny plus tau xz nz. sorry, tau y z, y z n z equal to 0, tau x z nx plus tau z y ny plus sigma z z minus sigma into n z equal to 0. So you will get this equation, right? So this is an equation. So what is our aim? What is our aim? So we might be knowing all this. If we know all this sigma is the principal stress, right? This sigma is the principal stress because this is the magnitude of t vector in that plane, in that particular principal plane, right? Because there are no shear stress, only what, normal stress. So students, this is the this sigma is the principal stress. Okay, so nx ny nz, nx ny nz, nx ny nz. So this nx ny nz correspond to that principal plane. So our aim is to find the principal plane. To find the principal plane means you just find the direction of cosines. That means nx ny nz. Okay. So how to get nx, ny, nz? If you know the value of sigma, you should be knowing the value of this sigma xs, tau xy, tau xy, tau x. This is tau xz. Okay. All those, if you know the value of stress at that particular point, the state of stress at particular point is known. So you have to calculate what? You have to find principal stress and principal plane. So you don't know sigma. Sigma equal to question, nx equal to question, sorry, nx equal to question, ny equal to question, don't know, unknown, nz equal to unknown. So all these things. So this is principal stress. These three corresponds to the direction of cosines of principal plane. But you know, nx square plus ny square plus nz square equal to 1. So this identity you should always you should be remembering. Okay. So I will show you how to calculate principal stress and principal strain using determinant method. Have you learned about using determinant to find the root of cubic equation? This will be a cubic equation. So students, this is the three equations we have derived. We have reached in the previous in the previous slide. So I have written that equation in matrix form only. So sigma xx minus sigma into nx plus tau xy into ny plus tau xz plus nz equal to 0. So that is the way of writing this equation. So you have three equations with these are the unknowns, ny, nz, nx, ny, nz. Sigma is also unknown. Don't worry, just keep it like that. If all these three, so you have a trivial solution for this equation. You can solve it for nx, ny, nz by putting nx equal to 0, ny equal to 0, nz equal to 0. So that is a trivial solution. But to find non-trivial solution, you have to take the determinant of this matrix. I hope you have learned these methods in our previous engineering mathematics class, solving cubic equations. So this is a cubic equation because you will be having root of sigma as the degree of sigma will be sigma cube. Okay, that is a cubic equation. So you have to take the determinant. So students, there is a term called non-trivial solution. Now to find non-trivial solution, you have to take the determinant of the coefficient matrix, and that should be equal to 0. So this equation is should convert into equation form. You will have a sigma cube here. Sigma, after you find in the determinant, you will get some long equation with the sigma cube. So it will be a cubic equation, right? So you can solve it for sigma. You know other values, sigma x's, tau xy, tau xz, all these values are known. So you can solve it for sigma only. I will show you. I will show you. I will show you. All this value is known, this known, known. All these things are known. The only unknown here is sigma, right? So if you find the determinant of this matrix, you will have an equation in sigma. You will get a sigma f of x equal to f of sigma equal to 0. Some function in this form. So here degree of sigma will be 3. 3 means some sigma cube will come. So this is a cubic equation. So you can solve it. Cubic equation will have 3 roots, right? So sigma will be solved as sigma, some 3 roots will be there. Sigma 1, sigma 2, sigma 3. So 3 roots means you will have 3 principal stresses. 3 principal stresses means 3. It means 3 principal stress and 3 principal plane. 3 principal plane. Okay. Hence with each sigma, that is each sigma means sigma 1, sigma 2, sigma 3. So there will be an associated plane. So these planes on each of which the stress vector is wholly normal are called principal planes, and the corresponding stresses are principal stresses. So since the resultant stress is always along the normal, what will be 0? Tangential stress component on principal plane is 0. Okay. So students, if you do the determinant, if you try to find the determinant of that determinant, you will get an equation like this: sigma cube minus sigma xx plus sigma yy plus sigma zz into sigma square plus you will get a term like this bracket determinant of sigma y tau yz tau zy sigma z plus sigma determinant of sigma y means y itself, x means x's, z means z. So you don't confuse. Sometimes I will write sigma. In case of sigma, it is not required to write sigma xx or sigma zz or sigma yy. Sigma x is, if you have written sigma x, it is understood that it is sigma xx itself. So, x is tau xz tau zx sigma zz plus sigma xx tau yx tau xy sigma yy. Okay. Into this into sigma minus determinant of tau ij equal to 0. Students, if you do the determinant, you will get in a simplified form like this. So here sigma cube minus sigma xs plus sigma yy plus sigma zz into sigma square, and plus a term in bracket into sigma here, into sigma minus determinant of tau ij. Determinant of tau ij means sigma xs, tau ij is what? What is tau ij? Sigma xs, tau xy, tau y is the determinant of that particular matrix. Alright. So students, this equation I am writing it as, I am just simplifying. Okay, I will. So I am writing this term as I1, I1, and this term inside bracket as I2, and this term as I3, I3. Okay, so the equation will become sigma cube minus I1 sigma square plus I2 sigma minus I3 equal to 0. So the equation is reduced to this form. So here students note down I1, I2 and I3 are known as stress invariants. Stress invariants. Okay. Stress invariance. So what is stress invariance? What is the physical meaning of stress invariance? I will write I1. I1 is nothing but sigma x or xx plus sigma y or yy plus sigma z. I2 is nothing but sum of three different sigma x tau xy tau yx sigma y plus sigma y tau xz, so sorry, tau yz tau zy sigma z plus sigma x tau xz tau zx sigma z. So this sum of these three determinant will be I2, and I3 will be determinant of tau ij. Tau ij means sigma x tau xy tau xz tau yx sigma y tau yz tau zx tau zy sigma z. So this determinant is I3. Sum of these three determinants will be I2, and this will be I1. So these three I's are called stress invariants. Stress invariant. So what is the significance of what does invariance means? Invariant is nothing but invariant is one whose value does not change when the frame of reference is changed. So here I have done all this calculation based on x, y, z Cartesian coordinate. But if I am taking another coordinate system x dash, y dash, z dash, I'm calculating all those the things I have done up to the previous slide. If I am calculating all those things based on another reference point, another frame of reference, x dash, y dash, z dash, uh, with the same point, I'm calculating the principal stress for the same point. So if you calculate with respect to this frame, you will get sigma xx dash, sigma tau xy dash, all these things based on new x dash y dash, tau y dash x dash, sigma y dash, all these things. You will get new terms, right? All the new terms based on new frame will be getting, right? But students, but the value of I1 I2 and I3 won't change even if frame of reference is changed. So that is why I1, I2 and I3 are called invariant. Invariant means it won't vary with respect to the frame of reference. Won't vary. Won't change means won't vary. That is why invariant. Okay, so the value of I1, I2 and I3 will be same. So you calculated I1 based on xy frame. I1 will be sigma xx plus sigma yy plus sigma zz, right? based on x dash y dash z dash, it will be I1 will be what, x dash plus sigma y dash plus sigma z dash. But since this is invariant, these two values should be its value should be same. So you can write sigma xx plus sigma yy plus sigma zz should be equal to sigma x dash plus sigma y dash plus sigma z dash z dash. That is the property of invariant. So even if you calculate, but sigma xx will not be equal to sigma x dash. Okay, since these two are calculated based on different frame of reference. Similarly, sigma yy won't be equal to sigma y dash, or tau xy won't be equal to tau x dash y dash, won't be equal. Any other quantities won't be equal when calculated in two different frame of reference. But I1, I1, I2, I3 based on uh, it will be equal to I1 dash, or it will be equal to I2 dash, will be equal to I3 dash. So only these three components remains unchanged or remains invariant if even if the frame of reference is changed. So that is the idea of stress invariant. Okay, stress invariant. So students, I will do a problem. I will show you to do a problem also to find principal stress, principal strain, stress invariance, and all. Then you will all those things will be more clear to you. Students, state of stress at a particular point is given by stress tensor 3, minus 1, 1, minus 1, 5, minus 1, 1, minus 1, 3 kilopascal units. You are asked to find three invariants, principal stress and principal strain for this particular point having stress tensor 3, minus 1, 1, minus 1, 5, minus 1, 1, 1, 3. Okay. So how to find stress invariance? How to find stress invariance? So stress invariant is nothing but I1 equal to sigma xx sigma y plus sigma z. So here sigma x equal to what? 3. Sigma y equal to 5. Sigma z equal to 3 again. So I1 will be 3 plus 5 plus 3 equal to 11 kilopascal. Okay. I1 is calculated. Similarly, I2 equal to sigma y. What is equation? Sigma x tau xy tau yx sigma y plus sigma y tau y z tau zy sigma z plus sigma x tau x z tau, these all are taus. Okay, tau z as sigma z. Okay, you have the value for I think 3 minus 1 minus 1 5 plus sigma y is 3 1 1 3, right, plus sorry, not 3, I think sigma y is 5, right, 5 minus 1 minus 1 3 plus 3 1 1 3. So you will get final value as some 36. If you do the calculation, you will get 36 kilopascal. Similarly, I3 is nothing but determinant of 3 minus 1 3 minus 1 1 minus 1 5 minus 1 1 minus 1 3. You will get the value as 36. You know how to calculate the determinant, right? So I am not going to show you how to find the value of determinant. I am just writing this final equation, final answer only. 36. This value also 36. You please check it on your own whether the value is correct or not. Okay, you calculate on your own. So we know equation, we know the characteristic of the equation is it takes the form iq. The characteristic equation is iq minus i1 sigma square plus i2 sigma minus i3 equal to 0. So here we have sigma q minus i1 is nothing but 11 sigma square plus i2 36 sigma minus 36 equal to 0. So this is an equation, a cubic equation. So if you solve this equation, you will have sigma equal to, sigma will take some 3 values, 3 roots, right? Sigma will have 3 roots because since its degree is 3. So you can use calculator, scientific calculator to solve this problem, solve this equation, or you can use eigen value, eigenvalue and vector, eigenvalue and eigenvector method to solve this equation. Uh, so you will, if you solve, or you can use scientific method, scientific calculator. In any way, you just try to solve it on your own. If you are not able to solve this equation, you please contact me, or you can contact your mathematics teacher. So he will explain you to how to solve this. So since this subject is mainly we are studying mechanics of solids, I won't be able to explain all those mathematics, basic mathematics equation or techniques to solve cubic or parabolic or any kind of equation. So I won't be explaining. It should be understood. You should be ready with those techniques when you are entering to the higher semester and all. So hope you know the method or you know the technique. Okay. So if you solve that equation, you will get sigma as 3 values, 6, 3 and 2. Means sigma 1 equal to some 6 kilopascal, sigma 2 equal to 3 kilopascal and sigma 3 as 2 kilopascal. So these are the principal stresses. 3 principal stresses are possible. So these are the principal stresses. Okay. So, but you know the equation, but you know our principal stress equation, sigma x minus sigma tau x y, tau x is tau x z, tau y x, sigma y minus sigma, tau y z, tau z is x, zx, tau zy into nx, ny, nz is equal to 0, right? So this was our equation, right? So here now you have got sigma, all the sigma values are got. Now only unknown is nx, ny, nz, right? Nx, ny, nz. So how to calculate nx, ny, nz? So you substitute all this value, substitute all the value, okay? Substitute all this value. So you can write, you will get values as 3 minus 6, minus 1, 1, minus 1, 5 minus 6, minus 1, 1. So now I am taking the first case. Take the case, take a case with sigma 1 sigma 1 equal to 6. So here I am applying sigma. In case of sigma, I am applying sigma 1. So 3 minus 6 minus 1, 1 minus 1, 5 minus 6 minus 1, 1 minus 1, 3 minus 6 equal to nx, ny, nz equal to 1, 0, 0, 0, right? So the equation gets simplified to minus 3, minus 3, minus 1, 1, minus 1, minus 1, minus 1, 1, minus 1, minus 3, nx, ny, nz equal to 0. But we know the equation x square plus ny square plus nz square equal to 1. So we have two equations right here. Okay, since we have already one equation, Okay, using these two equations, you try to solve. So, so I am writing this equation first. Okay, minus minus 3nx minus ny plus nz equal to 0, right? Similarly, again I can write minus nx minus ny, second one, minus nz equal to 0. Also nx minus ny minus 3nz equal to 0. Also we have equation nx square plus ny square plus nz square equal to 1. So we have 4 equation, 3 unknown. So you can easily solve this. You can easily solve and find nx and y answer, right? So from equation 1, minus 3nx minus ny plus nz was equal to 0, right? So here nz equal to 3nx plus ny. Similarly, from the second one we will get minus n. So keep it as equation 1. Okay. So from the matrix you will get another equation. Second equation as minus nx minus ny minus nz as 0, right? So here nz equal to nz equal to minus nx minus ny, right? So keep it as equation 2. So if you add 1 and 2, you will get 2nz equal to some 2nx, right? 2nx. You will get nz equal to nx. So this is another. Keep it as 3. Okay. So from the you substitute this value in our second matrix equation was like nx minus ny minus nz equal to 0, right? But nx equal to nz you have got, right? So you substitute this equation here, you will get nx minus ny minus nx again equal to 0. It will gives minus 2nx equal to ny, right? Or ny equal to minus 2nx equal to minus 2nz, since nx and ny are same, nx and nz are same. But nx square plus ny square plus nz square equal to 1, right? So you substitute nx as nz square, ny as minus 2nz square plus nz square equal to 1. We will get 6. Total 6 nz square as 1. You will get nz as 1 by root 6. Okay. Now this will be equal to nx itself, and ny will be equal to what? Minus 2nz. So it will be minus 2 by root 6. So the n vector will be 1 by root 6 I, okay, minus 2 by root 6 j plus 1 by root 6 k. So this will be the n vector for principal plane corresponding to principal stress equal to 6 kilopascal. So this is only one n1 vector, first principal plane. Similarly, if you substitute sigma 2 in case of sigma, you will get n2. Similarly, you can calculate n3 based on sigma 3. So this is the basic idea of finding principal stress at principal plane. So hope you have understood. I think you won't be asked to find principal planes, but you just try to understand what actually is principal plane. You won't be asked to find principal plane in case of, in your exams and all. I don't know. If at all asked, no problem. You can find in this way, but it is a little bit time consuming. That's only worry. I hope you have understood the concept. So, in the next class, we will do some diagram, the same. We will try to find principal plane and principal stress using some technique called Morse circle. It is a geometrical method to find the principal strain and stress in Morse circle in case of 2D. Here we have worked in 3D, three coordinate system. Morse circle is applied only in 2D cases. Okay, thank you.